Okay, your question scape now, okay, I repeat one more time, sir. We want to solve the homogeneous system. This case, you have the complex eigenvalue. This is negative. Negative 1, negative half y. Okay, this is a system y prime equal to ay. Okay, y prime equal to ay. Okay, as I said, okay, first step 1, you need to find eigenvalue. Find the eigenvalue. You have okay, A is 2 by 2, you should have 2 eigenvalue, lambda 1, lambda 2. Find your lambda 1, lambda 2 from the system, from the determinant of A minus lambda I equal to 0. Okay, this one I think from the homogeneous system, okay, initially I did show step by step, but maybe you didn't focus and you are, okay, I'm not sure what happened to you, but at beginning of the first lesson, before the semester break, I did show already why it is a determinant A minus lambda I, why you just deduct at the main diagonal. Okay, and y is determinant of y we solve from determinant of A minus lambda I equal to 0. Okay, this one also, okay, from yesterday also we already said we assume the solution of y is actually eigenvector v multiply exponent lambda t. Okay, this is one of the solution. We assume one of the solution is eigenvector v multiply exponent lambda t. That's why we need to find eigenvalue. First step, later on, for A 2 by 2, you should have 2 eigenvector v1 and v2. So means second step, you find eigenvector v1. Third step, you find eigenvector v2. Later on, your solution. Okay, so later on, your solution will be, you have the v1 exponent lambda 1 t, okay, plus b v2 exponent lambda 2 t. Okay, so I repeat one more time. Y, to solve eigenvalue, you have to solve determinant A minus lambda I equal to 0. Because you have the system y prime equal to ay, y prime equal to ay. So mean y here will be replaced by v exponent lambda t. So you need y prime. To get y prime, you differentiate respect to t, where v is a constant. That's why you differentiate this one, you get okay, lambda also a constant, v is a constant, so you get lambda v exponent lambda t. So you substitute okay, y prime into here, and then you substitute your y into here. So you get the system, okay? You substitute these two things into, you substitute these two things into y prime equal to ay. So you have okay, lambda v exponent lambda t equal to a. Y is actually v exponent lambda t. And then okay, we can cancel out, as yesterday I said, we can cancel out exponent lambda t, exponent lambda t. So you have a v minus lambda v, okay, equal to 0. Okay, and then a minus okay, y we multiply by I. Because A is a 2 by 2 matrix. So in this case, okay, your A is negative half. Okay, this negative 1, 1, negative half. Okay, lambda is a constant value, lambda. So okay, a 2 by 2 matrix you cannot minus with a lambda, but you can multiply, or you can multiply, but you cannot minus or add up. That's why we need to multiply with an identity matrix. So this one 1, 0, 0, 1. Okay, this is eigenvector v. I can cancel out exponent lambda t because each hand side, but I cannot cancel out the vector v. If I cancel out, then we cannot find anything. If I cancel out v, means that v is equal to 0. You cancel out already. So from here, by assume y, assume the y is mean what we do is actually we assume y is actually the solution of y is v exponent lambda t. Then we arrive at the system, at the homogeneous system a minus lambda I v equal to 0. This is a homogeneous system. Because right hand side here is 0, homogeneous system, this is 0. And in this case, v cannot be 0 here. V cannot be 0. If v 0, then your solution, you have no solution. Because if v 0, then your y is 0, so you couldn't find the solution. So the only way to get the solution is let determinant of a minus lambda I equal to 0. So this one is simplify here. This will be the matrix. I think you know how to do the matrix, arithmetic operation, right? Negative half. I do it slowly. This one I did show it in the first lesson of homogeneous system. So now, that's why lambda we need to multiply by identity matrix so that you can do the matrix operation. So now y, you just minus lambda at the diagonal. Because here, negative half, row 1, column 1, you have to do, mark, subtract with the row 1, column 1 must corresponding cell. So 1, why we need identity matrix? Because, we just want the changes, because identity matrix is actually, look like, is if normal number is just like 1, it would affect, because lambda times I, you still get back the lambda, is like 1 in the normal number. So that's why, I already said, only first lesson I show it this way. And from the next lesson, you should understand a minus, mean a minus lambda I, straight away, you just minus lambda at the main diagonal. So this is v equal to 0. So that's why, only first lesson I show it this way. For the next lesson, when I said determinant of a minus lambda I, this one v cannot be equal to 0. V cannot be equal to 0. So the only way to be 0 is determinant of a minus lambda I equal to 0. To get determinants, your matrix, you just make it become straight line. So make it become straight line. So negative half, negative lambda, negative 1, 1, negative half, negative lambda equal to 0. So is it clear why you said minus lambda at is it first row, this one? This is what we said main diagonal.
Yes, I understand now.
And then what I want to comment this one. So now you should understand why we minus lambda at the main diagonal because of a minus lambda I. So mean first step, you have to find eigenvalue. To find eigenvalue, you let determinant of a minus lambda I equal to 0. And this case you get, you can easily, you just use a scientific calculator. You can easily get complex roots here, negative half plus minus I. And second step is the same like the first case where you have real and difference eigenvalue. The only difference is the last step you want to convert the solution in terms of cos and x, cos and sin to eliminate the imaginary number there. And in the YouTube there, I did this. Second step is substitute your lambda 1 into the system, homogeneous system A minus lambda, 1 I V1 equal to 0. General we have this one, A minus lambda I. So lambda, because you got two values, so lambda you change it to lambda 1, that's step 2. To solve your, to find the eigenvector, later on, first step you get your eigenvalue, and then the second step, later on, you find the V1, to find the V1 from the homogeneous system A minus lambda 1 I, V1 equal to 0. And then here, you may confuse, how, to reduce it to this one. Like in the first lesson, you got real and repeated eigenvalue. The second example, you have the imaginary, not imaginary, the floating point eigenvalue. So you are also difficult, or very confused how to reduce it to reduce it from 2 rows. How can I reduce it to only 1 row? If you confuse, the purpose we reduce, so that you can see that for homogeneous system, even though we have 2 equations, these 2 equations are equivalent. In 2 equations will reduce to only 1 equation. If you confuse with the row operations here, what I can suggest, you can use any rows here. You can take up either row 1 or row 2 without reduce using the row operation also can. Maybe I cannot write in here. So are you confused with the row operation or not?
No.
Okay. Because some of you may very confused how to reduce it. I change it to another form where I can write.
Confused.
Hold on. Never mind. If you confuse we solve it from here without reduce it. Also, we can get the solution. It's actually the same. Here. So this one you solve it, you have negative half negative lambda squared. So minus with negative 1 minus with negative 1 equal to 0. So take negative half minus lambda. So you expand here, this you have 1 over 4, 2 times negative half times negative lambda. So you have plus lambda squared plus 1 equal to 0. So you got lambda squared plus lambda plus 5 over 4 equal to 0. Then you can use your scientific calculator. Polynomial degree 2. So you have 1. Key in the coefficient of your polynomial. Divide by 4. So you have negative 1, negative half plus I. Another one is negative half minus I. So what you get here from a scientific calculator. Your lambda 1 is negative half plus I. Your lambda 2 is negative half minus I.
Doktor, 2 tu tak payah ambil ke? Cancel out.
Divide by 2. Ini pecahkan dia punya penyebut. Negatif setengah. Tolak 2 bagi 2. Dapatlah 1i. Okay. And then, so you move to your step 2, find V1. Okay, find V1 from A minus lambda 1, I V1 equal to 0. Okay, so you plug in the A just now, we have what? Negative half. Negative half, this is minus. Okay, lambda 1 is negative half plus I. Okay, and this value is 1, this is negative 1. So negative half minus negative half plus I. We want let it equal to x, y. So your substitute, this is a lambda 1. This part, this is a lambda 1, this is a lambda 1. Okay, and you simplify it. So you have negative half, negative is okay, plus half. So negative half plus half, okay. So cancel, you have so you just left is negative I. Negative I, this is negative 1, this is 1. Okay, again this is negative I. And x, y equal to 0. So okay, that row operation is actually purposely to show you, okay, the row operation purposely to show you these two equations, they are equivalent. Okay, you can reduce to only one equation. If you're confused, okay, you just take up any row that you like it. Okay, any row that you like it. Okay, let's say if you're confused to do, okay, to reduce it to only one row, then you just take up any rows. Okay, for example, let's say I take row 1. So row 1, I will have negative x, okay, negative I x, negative I multiply x plus 1 times y plus y equal to 0. Okay, that's why the y equal to ix. Okay, so y equal to ix. Now I let x equal to s, so y equal to is. Okay, y equal to is, then your xy, so x is 1, okay, s, y is is. So is it okay? If you're confused, just take up any rows only. So you can check it whether same with the, you can check it, is it same with the previous solution where we reduce it. So step 2, find V1, is it okay?
Yes, Doctor.
Okay, and then you move to step 3, you find V2. Okay, find V2 from A minus lambda 2 I V2 equal to 0. So you have is your A is negative half minus your lambda 2 is, what is lambda 2? Negative half plus I. And this is, this is 1, and then this entry value is negative 1. So negative half minus a lambda 2, which is negative half plus I. Then V2, let it equal to xy, so equal to 0. Okay, simplify. So against negative half minus negative half, so it's cancel. So you have this one is, now you just left negative I. Negative I, this is negative 1, this is 1, this is negative I. Xy equal to 0.
Doctor, was it supposed to be positive?
Yes.
Negative.
Lambda 2 is negative half, okay, plus I, right? Let's check it with this one.
Minus I.
Oh, minus I. Sorry. So it's same, huh? This one, okay. Oh, we already done the negative 1 plus half. So this one is a minus, okay? Minus I. So cancel. This is minus I. Okay. So this is positive I. Okay, and then okay, if you confuse to reduce using row operation, just take up any row only. Okay, for example, let's say we take row 1. So we have Ix plus y equal to 0. I multiply x plus 1 times y equal to 0. So y equal negative Ix. Okay, and you let x equal to s. So y equal to negative Is. So your xy you have, factor out the s, outside x is 1s, y is negative I. Y is negative I. Okay.
Tadi bukan letak video x to is. X equal to s.
Is, negative Is. So negative Is.
Tadi dekat YouTube tu x2 equal to is, y equal to.
Okay, because the YouTube one, let me check. This one I think this one is a negative. Okay. Okay, your eigenvector, if you take it different row, or you reduce it, okay, you will have different eigenvector. Because we have an infinite many solution. Okay, and okay, this one is minus half. Okay, let me see. Because okay, the YouTube one I reduced, okay, to only one row only. Okay, you see this one. Okay, for second eigenvalue minus I. This one is I1 negative 1. I1 negative 1 I. After using the row operation, my equation different with the original, okay, system already. This is x equal Iy, and I let y equal to s. And here this one is I let what x equal to s. So of course, okay, the solution you will have different eigenvector. Is it okay? Because if you let x equal to s or y equal to s, your eigenvector will be different. In the YouTube is, okay, just now I let y equal to s, here is x equal to s. Okay, beside using the YouTube one, I already reduced using row operation. This one I didn't reduce anything, I just straight away take from row 1. Okay, now you can see later on the final solution should be same. So this is your V2 is 1 negative I. And then just now this one V1. Okay, this V1 you have 1 I. So the step number 4, okay, your general solution. you have the y is actually a v1 exponent lambda 1 t plus b v2 exponent lambda 2 t. Okay, and then the v1 in this case, one I. v1, we got 1 I exponent. Okay, lambda 1 is negative half. I use plus, plus I t. Plus I t. And then the b v2 is 1 negative I. 1 negative I exponent. Okay, lambda 2 is negative half minus I t. You see the solution different with the previous one, but then later on we check it to be the same. So this one, okay, if you want, okay, later on, if you want to change the solution in terms of the cos, okay, and sin, we have to use, okay, exponent it is actually cos t plus I sin t. So if your exponent negative it, it will be cos t minus I sin t. So we are going to convert this part. Means the y you have a, this is 1 I, you have exponent negative half t. You break your exponential term here into the constant term and imaginary term. Exponent negative it times exponent it. Okay, plus b 1 negative I exponent negative half t times exponent negative it. 1 I exponent negative half t, and then exponent it is actually cos t plus I sin t. So you got b, this one is 1 negative I exponent negative half t. So exponent negative it is cos t minus I sin t. And then you can put it a exponent negative half t, and then you can take this thing and multiply. You take this vector, multiply, you have this vector multiply with this row. So first row is 1 times cos t plus I sin t. So you have cos t plus I sin t. And then I multiply with this row. So you have I cos t. I multiply I is I squared is negative 1. So you have negative sin e. So plus b exponent negative half t. Again, so take 1, this column vector multiply with the row vector here. So first row you have cos t minus I sin t. Then second row, negative I times cos t. So negative I cos t. Negative I times negative I is positive I squared. Right? You got negative I squared. Negative I you squared it is actually I squared. I squared is negative 1. So you have negative sin t. And let me check it. Then later on, we break it into, okay, this column vector, we break it into a vector dependent on only the real value. Another one is imaginary value. So you have a exponent negative half t. Here you have cos t minus sin t. Okay, then vector plus a vector dependent on, okay, imaginary number I. So you have, this is sin t, this is cos t. Okay, this is for A term. Okay, and then for B term, so B exponent negative half t. So you break it into a real, okay, value and the imaginary value. So you got cos t, okay, cos t negative sin t, negative sin t. Okay, this is minus I. So we got first row is sin t, second row is cos t. Okay. Okay, and now you try to, so you see, okay, if the real value, okay, just now, okay, in the YouTube, okay, I think I just stop at the real value. This one, right? Okay, the okay is stopping at the real value solution. Okay, cos t negative sin t, you see here, right? Cos t negative sin t, cos t negative sin t. Okay, in the YouTube one is actually, I stop at there, is actually still haven't finished. Because the A term and the B term, you look at the real value here, they are actually the same, right? This is A exponent negative half t. Okay, the vector is cos t negative sin t. For the B term, B exponent negative half t cos t negative sin t. This part, you look at here, they are actually same, right? Okay, can you, okay, comment on this one? These two terms, okay, in the YouTube, I stop at here, the real value solution. Okay, actually these two terms are exactly same. So the correct case solution should be, okay, the correct solution, A, we take it, mean the correct solution actually, I will take, okay, the A term here, I take the real value, mean the, okay, real value here, cos t negative sin t. Okay, if this one, if I take, okay, from the B term also, the real value will be same with, okay, the A. That's why I will take out this one. Okay, and ignore the I here. So B exponent negative half t sin t cos t. So this is a correct solution. So negative sin t cos t. This is minus. Okay, do you have any questions here? Just now the YouTube, okay, stop at here, is actually not yet finished because these two terms are actually the same, That's why, okay, for the solution, you take the real, okay, mean the real, okay, solution from A term, imaginary solution from the B term. That's why this is a final solution, like this. Because if you take out these two, they are same, okay? They are the same term. And just now you say, okay, my solution, this one is without row operations. This one, I didn't do any row operation. I just take out, you can actually take out either row 1 or row 2. But in the YouTube just now, it's actually, you may be not wasting, you may headache, okay? how so many steps from here. Then reduce up to here. You may hate it how to reduce, okay? But this one is to show you these two rows are actually the same. So to make your life easy, so I said you can just take up any row if you're confused how to do your row operation. Okay, do you have any questions here? Are you okay?
For now, okay, better.
Huh? Is it okay? Okay, maybe we can the second example. Okay, let's see the second example. Okay, continue the second example. Okay, or you want to do the tutorial?
I think the next example.
I couldn't hear. Can you speak a bit loudly?
Next example, Doctor.
Last example.
Yeah, sure.
Last example.
Yes.
This is example 2. You want example 3? This one.
Yeah, okay.
This one. Okay, so this one solve y prime negative 2, 2. Negative 2, 2, negative 2, negative 2. Okay, this is the last. Huh? What's that? Can you speak loudly? I couldn't hear. What you? Is it this one? Is it?
Yes,
This one, right? This is the third example. You want me to explain this one?
yes, Doctor.
Yeah, okay. So this is the example 3. We want to solve y prime equal to negative 2, 2, negative 2, negative 2 y. Let's see, negative 2, 2, negative 2, negative 2. So again, first step you find the eigenvalue. Okay, find eigenvalue. Find lambda 1, lambda 2. Okay, from determinant A minus lambda I equal to 0. Okay, so you put up determinant. So negative 2, okay, we straight away subtract lambda at the main diagonal. So this is 2, this negative 2 minus lambda equal to 0. Then you calculate determinant, use the main diagonal, the product of the main diagonal. So negative 2 minus lambda time, okay, so it's squared, or same. So minus the product of the other diagonal, so minus negative 4 equal to 0. I hope you know how to do your determinant. So expand your determinant here carefully. So negative 2, you square it is 4. Then you take 2, multiply negative 2, multiply negative lambda. It will be positive 4 lambda plus lambda squared plus 16 equal to 0. So you have lambda squared plus 4 lambda plus 20.
Why 16?
16. Oh, yeah, this is 4. Correct. Okay. This is plus 4. And then so is plus 8 equal to 0. Okay, and then you get your you get your lambda, okay, using your scientific calculator, okay, what do you get?
-2 plus 2
Yeah, I mean you just use your scientific calculator here. Key in 1, 4, 8. So you have -2 plus 2i, -2 minus 2i. So you got your lambda is -2 plus minus 2i. Okay. So first step done. Second step, okay, find your V1. Find V1, okay, from a minus lambda 1 I. V1 equal to 0. Okay, a is at -2. Okay, lambda 1, let use -2 minus 2i. So you have bottom, this is -2, this is 2. -2 minus -2 minus 2i. Okay, V1 let equal to xy, so equal to 0. So -2 minus -2, so become -2 plus 2, so you get 0. So this is negative, okay, and -2i, so you got positive 2i. So this is -2, this is 2. So again, this one also same. X, y equal to 0. Okay, and I said, okay, you can just use any row. Let's say we use the first row. So first row, you have 2i times x plus 2y equal to 0. Hence you get y is actually -ix. So let your x equal to s. So y equal to -ix. So your xy